where was that? If you want a simple souvenir of the whole repository, you can find it at github.com/IC/IC workshop EuroBioC 2025. Sorry for the mouthful. Which is then rendered. I got a same address as the mother of this repo, which is the iSEEde repo, which is like a advanced and even more extending workshop on this. You can spend 1.5 days in trying to go through the material. But first of all, welcome everyone. Nice to see possibly a couple of faces that never used iSEE and a couple of faces that probably already have used that. We are here to try and give you a little bit of the tips and tricks to get even more proficient to use iSEE. Who of you has never seen this tool? Perfect. Who of you has already used this tool and have the hope to get even more proficient with that? Okay, this workshop is for both categories. Cool. I'm gonna not use that. You can use that. If you do, okay, I'll keep on getting that. You should land to something that looks like this, and you will land basically potentially to a document which is in the vignettes folder of this package, which you can very much install. And then once you install it, it already automatically installs the dependencies, all of them that you need. And then you would have this very document, which I'm gonna try to maximize for you. I don't know if is it readable at all-ish from the bottom lines? I cannot control too much what the Beamer is giving me. I can try to maximize it like this so that it's.
You can use Control plus.
Yeah, I mean, like I can, but it will get possibly too largish, and then but yeah. Okay. Let's say I would take up the invitation or like the nudge from Helena yesterday in her keynote speech. She said, let's go back to basics. What type of plots do you normally use when you do single cell data analysis? What do you, sorry? UMAP. So what's a UMAP plot? It's a scatter plot. Okay, we have it. What else? Box plots. Okay, so something like a feature across some categorical variables or across a continuous one. You can, let's say, have something in the loop schemes. Okay, more heat maps. Okay, more violin plots. Okay, I go with here because it can be something that could be assimilated to that. You might also want to have some kind of, say, visual representation of tables. They are called Hinton plots, but let's say tables and then tabular representations of quantities. Okay, more volcano plots. Okay, depending on the context that you might need. Okay, more still scatter plot basically.
Feature plot, which would be a scatter plot as well.
Yeah,
feature plot.
Yeah, so, I mean they can be scatter plots that just cleverly arranged with the aesthetic. Okay, but I think we kind of cover. Okay, maybe instead of the heat maps or on top of that, we can have the bubble plots where you have the information of a heat map, and then on top you have this kind of let's say information encoded by the size or the radius that can probably tell you the percentage or the amount, and then you have the encoded color with the hue of that. But otherwise, I mean, like we have all of that, right? So, okay, maybe dendrograms, yeah, depending on what you fancy. And then upset plots. That's actually something that we don't have inside iSEEde, sorry. But actually, yeah, more. I mean, you would like to have many of these that are also potentially interactive and possibly talk to each other. And that probably takes a lot of time to do, redo, again, nudging to Helena yesterday when she said 6 months to get into the product, 2 weeks to do the analysis, and then 2 years to generate plots and generate plots and generate plots. Probably this can help you. Let's hope that it's the case. So in case you either install the package or you're working on the cloud instance, you could basically load all the dependencies that you need by simply executing this command. Maybe I can have the output inside here. Does it help? Instead of having it, the output of the chunks inline, and then I can maximize. Yeah, okay. In case we need the console, I can take it out again. Okay. So basically, this is just a rundown of the other packages that you might need, but they all came with the installation of the workshop package. First things first, I want to throw at you some data, like literally throw it to you. We just pre-process it for you, and that's nothing but the classical PBNC3K, so the classical immune data set that is provided by 10x, and it looks like this. So like that's pretty much what you would get if you would either download it from the 10x website. But on top of that, what we have done, we have added some cold data information and some other raw data, let's say, that could be useful to demonstrate some of the features that we need. So we have the usual 32,000 genes and approximately 3,000 cells. You might have seen already this kind of format. So is the single cell experiment and or the summarized experiment something new to you at all? So you all have seen this kind of printout of an object. Okay, perfect. So think of iSEE as something that is built right around this kind of class as a container, and then iSEE just knows where to pick the information that it's not hidden but stored and basically conserved and basically made available and accessible to you when you need to access that. What do we have in here? It's a couple of call data. Oh, that is odd as an error.
SingleCellExperiment
Isn't? Okay, interesting. Then let me just run this as well for you. Yo, good catch. Okay, thank you. Basically, we have a couple of QC-related call data that we have just added. And then on top of that, we have performed just a quick round of clustering. So we have, I think, approximately 14-ish clusters. And then we have annotated the cell types with the labels main, labels find, and the cell type on so the cell ontology terms that are coming through the single R. And on top of that, we've also added the labels so that they are readable. And just in case you wonder, well, this is actually a Bioconductor workshop, but maybe I'm working with Seurat or with Scanpy. Say, is this thing is quick? And it's yes, because there are some very good packages like Cell Converter, AnnData R, which is the probably, I would say, the updated cousin of Cell Converter, that within a couple of lines can actually take you to a single cell experiment object, which is also what you need. So like if you think that you are stuck in Scanpy, so in Pythonlandia, and or if you want, or if you don't want to escape Seurat because you think that iSEE might not do it for you, then you might be wrong, and then just one line of interconversion away. We have just covered this kind of question. And the second question for you would be, do you commonly, yes? Okay, sorry. Do you commonly present a collection of plots within a group meeting and or a group meeting with your collaborators? Yes. Is that a painful experience sometimes? Do you want to try to reduce the pain? How many iterations do you need till you get the final version? So like, is your PI easy to satisfy or not? And we would like to try to break these things down a bit so that you can see how you can either produce or reproduce with these plots within iSEE. And it's not a pinky swear thing, but it's really just boiling down to running this one command. If this is your data set, this is the only command that you need to run. So if you do so, you can obtain such an app. That's the vanilla iSEE, so to say. Vanilla iSEE because it starts with a couple of pre-configured panels. I have. Okay. Thank you. So it starts showing you quite a couple of things. And I wanted to just show you around a bit. So like we have a reduced dimension plot, one slot, so panel, and that unsurprisingly contained the information that is stored, for example, in the PCA, which is inside the reduced dim slots. We have a raw data table, which contains basically just the rendered and searchable and perfectly browsable form of the raw data, but just there for you. It has a feature assay plot. And the feature assay plot is nothing by taking the assay information and then something which is related to the features. In this case, it's probably pointless green because it's always not expressed. It's the first one in the rows. And then plotting it just like this. We have some column data plot. And the column data plot, in this case, is just it's just a piece of representation of a table. So these dots are individual cells. In a similar way, these dots are individual genes, not informative at all because we have all different sample IDs over there. And then we have our column data table. Connection was unstable. Let's see. Column data table, that's basically the pendant to the row data table that you have seen here. And then, of course, one heat map with one single line because we don't want to overload the startup phase of the app. But you all get this basically just with one command. And kicking in with you. So like, can we do a UMAP plot within iSEE? Yes, we have the reduced dimension plot. Can we do a box plot or a violin plot? Yes, we have the green panel, so the feature assay plot. Heat maps and bubble plots, we have the heat map over here. We have the bubble plot somewhere else that I will show you later. Can we do tables? Yes. Can we do tabular representation, so like abundances and so on? Yes, we can. Can we have volcano plots? Yeah, we can. We take the raw data and we plot the log4 change versus the transformed version of the p-value. Fine, fair enough. Can we do dendrograms now? No, we can't, but iSEE3. I get to that later. Can we do upset plots? No, we cannot. Now, but you just gave us an idea. Thanks. Because this thing still lives. An historical note on iSEE. iSEE was born on a not stormy, but still cloudy, dark, gloomy, cold night in December in 2017 in Cambridge. Where are the founding parents? Three of the founding fathers and mothers of iSEE are in this room. The fourth one is in the cloud. It's Aaron as well. So we've been sitting together. We had probably too much free time in our hands, and we decided that we had no tool that was doing these things with a couple of twists. So something about the interactivity, but also keeping in mind that it's cool to do reproducible things. And as I said, all we need is a summarized experiment. We have just gone through the different types of panels that you have within iSEE. There's a mouthful. You can read it, let's say, on the way home and so on. So let's just try to follow along. And if you have any questions, just like literally stop me anytime, and I'm happy to interrupt. What each of these panels have, and that actually controls all the essential things of what you show, how you show it, and how these things talk together, are these three set of parameters. You have the data parameters, you have the visual parameters, and you have the selection parameters. And I'm going to show you how they look like there. They normally, allow me to do one thing. I try to open it in the browser, where I can possibly control a little bit better how the zoom works there. So it's going to be a little small, possibly, but it will probably be better to read. Again, we are restarting the app over here. So that's going to be our standard PCA, because that's the first thing that you have in your reduced dimension plot. But what if you want to see the t-SNE? What you control it with the data parameters. You can simply say, I want to display the t-SNE or the UMAP plot. You want to use the first, the second. So the dimensions that are in there. And as you have heard yesterday from Susan, you shall store more than the two principal components. And if you do have more, then everything is just in here. We are not too good because we stored 5 instead of 50, as she said, but we can work on that. The t-SNE, normally you do store only the first 2. That's what we did as well. And then we can control how this looks like. Now it's just black dots, possibly not too interesting. So how these things look like, you can control it always with the visual parameters. And the visual parameters, there's quite a set of, let's say, controls. Normally, we always show the color one, but you also have control over the shape, the size, the point, the facet, and the text that you have over there. Typical plot that you every now and then might want to do is a UMAP plot or a t-SNE plot with the annotation of the cell types on it. So normally what I could do here, I can decide to color by a column data. And you see that you basically see the first of the column data that you have, which is not too informative as of now. But we scroll down and we see that we have the labels main that should also have a name, but I don't see that for some reason. It might be an artifact of the visualization. Let's see. But then I also want to, for example, I want to increase the size of the points, so I can change this. And you will see that I just made them a little bit thicker. I also can decide to have some text on it. And the text can be, for example, centered with the cell type names, which are visible. So that's actually funny. So you can see a little bit here, monocytes, dendritic cells, B cells. I can read that. I hope that you can read it at least on your screens if you're doing the same. And then there's a third set of parameters, which is essential to have the panels talk to each other, which is actually one of iSEE. And that's the selection parameters. Who's a bit familiar with Shiny of you? Who's not at all familiar with Shiny of you? There is one essential concept in Shiny, which is the reactivity. The reactivity is basically, I select something, I change something, and then something happens somewhere else. The panels within iSEE can be all selectively, they can be actually reactively connected to each other. So if I select something on a panel, then something can happen on that panel, on another one. So what I can do, for example, is that select another cells. So I take CD3E. I might want to take the x-axis and split it by the cell type of interest, or by the cluster number, for example. And then you will see that we have some cells that are CD3E positive and some cells that are not. What I can do is, for example, I can select all CD3E positive cells and pass on this selection to this panel. So I will receive the column selection, so the cells, the samples, from the feature assay plot. And what happens is that I am basically making the other cells a little bit more transparent. And when I select something else here, I will see a completely or slightly different set of cells that I have here. I can actually complicate this, not complicate, but I can actually make it more convenient. Who's working with immunologists of you? Who's liking immunologists? Who's not liking immunologists because they always have CDs everywhere? So CDs, their rooms might not be so tidy, but they might have CD3 something, CD34, for example, and they want to plot CD34. Can someone try to guess what's happening now? So I'm telling now this panel to pick from this column, from this table, that I just want to take whatever I select here, plot that thing. So it's a what? It's a data parameter. I want it here. I want it represented here, and I want it still connected to that. So all I need to do is, instead of having these three dashes, I am taking in the data parameters the selection of the raw data table. So whatever I select new, I can basically obtain live new plots of that. So let's take let's take CD3E again. And if I select CD3E and I select this one cluster, or the entire cluster to be more precise, I can see which cells I'm selecting over there. What's the limit here inside iSEE? It's basically, let's say RAM is the limit, and or the possibility of connecting these panels that you have, that's actually the limit. So you can pretty much do whatever you want, and we are just scratching the surface, we are just looking at the first three set of panels. So you can imagine you can have multiple panels linked to each other. You can have like in silico gating. You can do a selection of these genes and pass it on onto a heat map and so on and so forth. And then having a heat map and then subset it by, for example, the selection of cells that you might want to be interested into. It's easy to tell some stories and then make it compelling, make it interactive. And I'm giving you just one tiny little bit of, I would say, magic. Because before ChatGPT, we were thinking that it's useful to actually get you the meta-generated code. So like that's the one-to-one code that you would need if you want to reproduce exactly these three or all the underlying figures. You take this, Control-A, Control-C, Control-V, put it into a notebook, like a Quarto notebook, and it gives you exactly these things. It can be a super cool things for two reasons. Save your time. It can be a learning way, or it's a didactical tool to say, this is how you can actually do these plots. You literally start your session by saying, I need an SCE. So that's the only thing that you need to attach on top. And then from here on, you can just literally copy paste this code and it just works. So, I mean, this data, visual, and selection, these are the key of putting these things together, stitching them together so that you can actually tell not just one isolated plot story, but rather a little bit more of a cohesive story. Let me just go back to this again to see if I forgot something, but there's a data parameters collapsible box. Oh yes, something nice that we could actually, I mean, it doesn't make too much sense in this case, but imagine we had something like, I would like to face it, this plot, by the cell type, so by the condition. We don't have a condition because in this case it was, let's say, a non-replicated dataset. But let me do one thing. I can actually change some settings. So we have some control parameters or control setups over here. One of them is the organized panels. And we can decide to have a very large, up to 12. So like 12 is the maximum width. So it has 12, this is 6, this is 4. So you can have 4 panels by 3, or just like one very large one. And I'm going to do this very large one by saying 12, applying the settings. And what happens is I will obtain basically the same configuration that I had. Everything stays linked as it was, but I'm just having this one thing which is now very much larger. And now in the visual parameters, I'm saying I want to face it this by the facet options are coming here. Column data, and I'm going to say labels main. So I'm obtaining the split up t-SNE plot for all my cell types. if it's something interesting, you can imagine that you can actually have a very good eyeballing on the differential abundance between conditions. And you can actually have it, let's say, color by condition, split by replicates, so that you can actually have an idea of how reproducible and how robust your results might be. And there's a lot of things that you can do like this. Again, if we click now on the extract the R code, this thing will also have the option for faceting this. So the facet is coming. Let me just see. There has to be somewhere some facet. I cannot find it. Yeah. The brush, no? Where's that? Is it coming later? Up, no? Yeah, that's true. I could actually even change it, but I can Control F and say facet. So you can see that this dot plot, the ggplot dingo that I'm creating has this facet grid, which is picking the facet column selection that we decided, and that was labels main. It doesn't mean that if you edit something in the editor, then iSEE changes it back. So that's not how it works. So it's more like the other way around. Let me just give you a brief rundown. We have seen the visual parameters. We have seen the selection parameters. We are seeing a little bit more on the additional controls. So we have this top right part that we started already seeing. I'm just going to click them, say, one by one, and then I can tell you what's happening there. This one is what we have seen already. So like we can take all the components, we can move them around as we prefer. We can actually what we are displaying by just removing them. So the ones that we don't want, we can add another one in case we wanted another one, and it will have a default width of 4. And that's how I want to have my app. I can apply the settings, and then iSEE re-renders it for you. So table is still there. What we were looking for is still there. If I change this, then this also will change, and so on and so forth. And then, of course, this one has a different non-selection. But then we have our old, like the new default reduced dimension plot panel. What we normally do is that we start, for example, possibly from a clean slate, we start exploring, and then we want to somehow save the state of the application. You can actually do that. You can, first of all, actually check how your panels that you have there, how they talk to each other. So for example, what is happening now is that we have the feature assay plot 1, which is passing the information to the reduced dimension plot, so that's actually represented by that arrow. But if you want, you can actually have this initial configuration, which is also like an object. And this object is a possibly complex to write list, but you don't have to write it because you can actually have the display panel settings, which is basically that's a counterpart of the code for the plots, but this is actually what stores a list, which you then fill in with the raw data table 1 information, the feature assay plot 1 information, and it actually stores it in a way that if you take these things, copy paste it in your script, in your object, in your session, you can have this initial object that is then something that you can store and you can pass as a parameter to iSEE. So it's not anymore just iSEE SCE, but it just literally, it's going to be like a initial, and then I can say, I want this to be my initial object. So you can imagine that this is a typical situation where you can say, okay, I've been spending some time to put up together a fancy configuration, and I'm starting my lab meeting. And I don't want to enter that by just having to reconstruct everything from the scratch. So what I'm doing, I can just simply save the initial list, and then I can have multiple initial lists. I can have initial done by Jérôme. I can have the initial take, let's say Charlotte, because Charlotte had a different view on those data sets. These are just objects that I can use and select to start the app with. And then there's the PI view on that. And then he will also have potentially his initial set of configurations. This is the I would call it like the prepare the next lab meeting presentation slide set button, because you can actually say in one go, you can click on download and it takes the output of these panels, zips them, and then you can give you like an archive that you can possibly, let's say, unpack, put into a PowerPoint present slide, or even better, I would say, you go into the lab meeting and then use that as your presentation means. Then the extra QR code, you've already seen that. This one here, this documentation, it's to open the vignette or to help you drafting a tour, or you can take a quick tour. The tour does not work in this case, but I can show you how any tour could look like. Whenever you see this question mark for any of the panels of iSEE, we wanted to give you something that you actually in-app have a way to highlight some components of the app, and then you can simply click on the next buttons, and then we suggest some actions that you can take, so that if you do what the actions are telling you to do, and then you click on the next one, you can just simply get a spotlight on something else that you might want to fiddle around and to toy with, and then some suggested information on how to make the most out of each panel. So each of the built-in panels within iSEE, they come with these kind of tours. And you can imagine that this tour is a perfect way, for example, to take a legend of your figure of the manuscript and make it live. Because you can start, for example, by welcoming someone that comes to your app, and then you found something cool and you want to talk about it, and then you're just putting like a spotlight on the individual aspects of that. And you're inviting them to feel free to change anytime the genes that you're displaying, because that's actually what you can actually do with this. I don't give you a static version of the figure. I empower you taking, I'm not saying it's not taking ownership, but it's them not having to download an H5AD object, a Seurat object, a SingleCellExperiment object, or just like going to some place. It's basically just, or the GEO, even worse. I hope Sean doesn't hear me right now, but it's recorded, so it's no problem. But you don't have to download a count matrix, process things, and then you don't know how we've done that. You take one object, that object has it all, and it contains all the information that you need, which is actually one of the main points that could be detrimental to iSEE. We've been asked a couple of times, well, can't you just do the analysis live like this? And it's actually, let's put it like this, it's a design decision. We decided to say analysis first, exploration then. Because the analysis is what kind of, let's say, where the good thoughts can come, then the question can come, and the questions can come during the exploration phase. So you might need to go back to the original object and do some additional steps, but that's how it's supposed to be. And also at the same time, we didn't want to chug whatever shiny server for running something in a reactive way, and whenever you change something and then possibly like you kill the resources that you have available, you shouldn't do that. So we're talking about the panel options. We have the visual parameters. What do we have else? Okay, we actually have this info. So this is just a session info reported for you there. So in case you wanted to just report it for reproducibility sake. You might want to know something more about iSEE. Or you might want something about this data set. So like in case you cared about putting something in the metadata slot, because that's, let's say, the unsung hero of anything chaotic can go in there, you can have a list viewer representation of that. So you can, of course, you can export this as to a JSON file, but that's basically like the content of the metadata, which might tell, for example, that we have run a couple of things from the, no, that's not too much in there, but that's fine. I mean, imagine that you use SCDBL Finder, for example, to detect the doublets in your data. SCDBL Finder silently puts quite some information into the metadata slot. So you can access that there. And then again, it's to put all things into one place. And then iSEE can also read that for you. There's that, and there's the button that probably, I don't know if it's dangerous to click on that, but if you want, you can stop and kill the app. So, but not for the sake of this workshop, at least. Okay. Let me see what comes next. We have seen how we can organize the panels. You can imagine that all the panels that you have just seen, you can just move them, toss them, put them back in, change some configuration, have it as you like, and then, of course, store the final configuration that you want. We have seen how we can go down the rabbit hole by linking the panels to each other, transmitting the selection of one panel to the other panel, and then this panel goes back to the other panel and to another panel. You can do, for example, if you work with mass cytometry data, you can do in silico gating, selected double positive cells over here and take them into the next plot and then take them into the next plot. So you can do that, and or you can select, highlight things. You can, for example, let's just try to do one tiny little thing. Let's go back and pick, for example, the complex heat map panel that we could populate with something meaningful. What is which of these parameters? In the data parameters, I can select what genes I can display. Can someone immunology affine among you suggest me some genes that might be interesting? Which is cell P.
SCLL.
SCLL. Mm-hmm. I can also say, I can say selectin, and then iSEE would basically comment that out for me because it will recognize that it's not inside this object. So like you will not have an error because the gene name will not be correct. So a little bit more, I don't know. Let's go with the classical useless ones, actin beta. You can say GAPDH. So let's go more housekeeping, but we can have ITGAM. Is it there? ITGAM. Let's see, is it there? It is there. So let's just select these 5 ones here. And then you can see that just by clicking on the validate names and then that was the I here, we can also actually order them alphabetically, and it will change the way that we render them. You can actually, if you are familiar and if you like keyboard shortcuts, you can use the Option key on the Mac. I think it's the Alt key on Windows, and you can just move things around. So like if you want to reorder rows, it's actually quite fancy and quick to do. You can decide to display the counts instead of the log counts, because inside the object you have the counts and the log counts. If the log counts are not in there, you will not see the log counts here. What you can do, you can cluster the rows because they might have some kind of similarity. You can put something on top of it. You can control the way how it looks like. How it looks like will be controlled by the visual annotation parameters. And then I take an annotation. I might want to say, I'm going to take labels main. And actually, I can also put more than one. I say labels main and cluster. And what I will obtain, I can put like out of the blue, so the cluster 1 chooser. So these are the number of the cluster. It's normally ordered by the first one that you select. So if I change that to being like this, it will, of course, put the cluster first on top without splitting them, and then it will change the labels here. But I can color by, where is that? I can select the parameters. I can receive the column selection from the feature assay plot. So if I select CD3E again, I take this cluster here. And now you have seen that we have the additional annotation for the points that I just selected, and it's also added over here. So like you have this, that, and also this one that takes over for the ordering. We can have more, and then let's say all the things that basically depend on the selections that I've just done will be automatically re-rendered within iSEE. Download panel output. So okay. I think we are, let's say, done with the iSEE as it is. So the main core of this part is what can we do with this? And we can go through the, let's say, the text part over here, and I can show you how it can be done, and or you can actually help me to do it. So if you want to, if you feel confident in like dictating what should I do, then we can simply do that. And then I will show you something more on the old things around iSEE, which is a collection of packages that might have some kind of features that might be useful for you. Are there any questions so far?
Not a question, but if you could demonstrate something for me.
Yes.
Because I was stupid enough to pack this instead of a laptop. So
Okay.
I can try on my own. One of the most common operations I perform is when I cluster, I try to plot the mean reads per cell.
Mm-hmm.
Sorry, I'm not really clustering.
It's okay.
Just to see if the ones which aren't being clustered properly have far few reads.
Mm-hmm.
So I think that should be possible with iSEE with a separate plot.
Okay.
If you can just.
Do you want to try it out? Let's say I can guide your hand, or like, or you can stay there. But yeah, whatever you prefer. If you feel confident in using my laptop, I'm happy for you to try to do so.
Sure. When did the last 5 minutes?
No, don't ask. So what kind of plot would you have?
Let's have the cluster.
Yeah.
As the first plot here.
Okay, so like the
Oh yeah.
like on a Disney plot.
Yeah, I mean this works.
Okay, let's just go back to the classical one. I select the visual parameters. I unfaced this plot. I need to actually select here the facet by and say none, and I'm gonna make it again smaller, so like it doesn't look too oddly wide. So, and I'm gonna put it back. Let's say taking half of the line, and I'm gonna put it back on the first row. Huh?
Yep.
Okay. So you could have, for example, you might want to do the color by
The reads.
the number of reads assigned to each of these cells.
Yep.
So you just need to know where this information is.
Yes, but I also had another idea thanks to your intuitive the way you work. Maybe I can have another plot here which plots the number of reads per cell.
Yeah.
And then I can also select and visually filter out.
Perfect. Yeah. Let's do it. Yeah.
Possible.
I think you might need a reduced dimension plot here, and you might need a call data plot there.
Yep.
Let's see if we already have it. We do. And then I'm just gonna put them side by side, taking, say, half of the space for both of them. We need to think what, and we need to think how. So you just said we want to have on the x-axis, for example, the cluster or the cell type. So we say the x-axis should be the column data information, and it should be, let's say, cluster.
Well, let's not do cluster. Let's just have
just have them in. Okay, then we say none, and then we simply. So in this case, this is a one-dimensional table, but you have something continuous, which is, for example, the
reads
sum or the number of detected genes. So I'm going to take the sum. So the number of detected reads, you have it here.
Yeah.
What you can then do here, let's imagine that we are not taking any selection anymore, at least not from this one here. So we already have our Disney plot. We already have assigned some cell type, but you might want to see where are the cells that have most reads. So you just select them here, and you can pass it on there, and then you can see that they might be, let's say, a little bit sparse around. So
let's select the ones with the on the lower end.
So the lower end, so we might have already kind of filtered them out because we have been pre-processed, we have been kind of QCing and cleaning this up already. But imagine that you have a dirty data set, like the real one. So the real one, the next data set. You can do that. So
actually, very curious. Can we still just try maybe with the lower?
It's not that touchscreen, but you can do whatever you want. Like I didn't take any snapshot of my any feed.
How do I get rid of the older selection?
The oldest, that's something that we still might need to investigate with the Shiny team, which kind of still has no answer. The closest solution for that is like moving a bit this and or trying to re-render the whole plot, but don't put the blame on us for that.
It's okay, but can we reset?
Yes, like not have any selection. Yeah. You can. Yeah, like clicking here and or clicking somewhere else. Yeah, so like you can simply move this one here and move this one back, and that should normally clean the selection. This still stays somehow this kind of kritze-kratze, which it's not close. That's the thing. Let's say I'll take this chance to show another feature that was not highlighted, at least in here. But I can also, instead of selecting rectangular selections, here in this case it's not too useful. Let's do it from here actually. Let's do it the other way around. So I'm gonna pass the selection from this one here to that. So I want to capture something which is not possibly the most rectangular selection. So it can be a concave selection for whatever reason, but you can select this by brushing in a very clunky manner, but still works. And then you can have that. And in case you wonder, is the code also mirroring those? Yes, it is, because it kind of saves the polygon for you.
Nice. I'm gonna go star your repo right now.
Thank you. The cheap way of actually winning stars.
Can you show how you did the switching the reactivity going from the right-hand plot to the UMAP again? So how did you switch, which was being the selection tool was?
So I basically, what we don't have, we cannot have a cyclic dependency. So we need to first, let's just do it. Like if I want to say, I want to pass this to that and that to this, it will tell me, no. So I need to first turn this off, and then I can turn this on, but that's all. And then I can say, oh, I'm gonna select this nested tiny odd thing, and I need to close the polygon, otherwise it will not work, but then you can.
That's not the selection.
Yeah. So you can always keep the selections. That's actually the beauty part. So this stays there. It's just that it's not there. You can actually have multiple selections, but that's probably that's material for the I use iSEE. I mean, just to show you that you can save selections. So I can save this one here. I can take this one there, and I can take the third one. And then I can have multiple selections, and then I can use the first, the second, and the third, the union of those, I guess. So I'm not saying that you can think, oh, then I can do differential expression live, because, or marker gene selection line, because you can. More questions, or otherwise, please.
Questions and comments. I like it very much because it's a kind of C loop where you can do all clicky, but then you have all the comments recorded, which is what you're missing, and to show all the collaborator. So congratulations first.
I'll share it with the others.
You have worked on the main plots, and this is for a summarized experiment as far as I see. So we could use anything, any kind of information stored in a summarized experiment. So as far as I have seen, there is no range, so there's nothing genomic in the plots. do you plan to incorporate?
Do you want an authentic answer?
Honestly,
The honest answer, yes. It's tough. I mean, we have been trying to have something that could accommodate region-based analysis, ChIP-seq, ATAC-seq. It's tough because, let's say,
information plotted in a I don't know, in a curve plot, in a circus plot, GBs, you know, like specific, but just for as a plot.
Well,
incorporating the G ranges information.
Yeah.
The genomic.
I would say that, I mean, like, just looking at the audience right now, I mean, we have Nat here with CarioPlotter. Nothing forbids to put.
Mention the Cario.
Yeah. So, but one could write a particular custom panel of iSEE Your question came up in other forms, for example, in the form of, oh, I have ATAC-seq data, and I would like to see that here. The problem is that ATAC-seq data, most of the time you want to, let's say, you want to keep it at, let's say, region-based. You could simply do one thing, and then you are back into the rectangular format perfectly. You compute the gene activity scores, and then you use it as if it was like a table. But sometimes you want to see the peak. Sometimes you want to see the signal coverage. And that is actually, for the only problem is, let's say, there's not just one way to do that. One could just simply have, let's say, these objects dangling around in your sessions. Or maybe you can actually think, okay, I'm going to use the metadata slot. I'm going to thicken that up, plug in all the bigwig files and the things that need, let's say, I can tell where these information might be. And then you develop a panel that feeds on that information. So it's like a genomic coordinates one, and you could. Maybe it's going to be too huge because you know how large ATAC-seq data might be. It could be super interesting. I mean, it could be like simply like, I mean, ATAC-seq data, single-cell ATAC-seq data aggregated by cluster, that's already tough to fit into this. Yeah. Yeah, proof of concept by Pierre-Luc. So like someone was brave enough to venture into that some time ago. True. Yeah.
You literally just implied it 20 seconds ago, and everyone may not be familiar enough with iSEE to know it. So we're kind of jumping like a few chapters forward. You can design your own panels, right? So the interface, iSEE version, we are currently at iSEE version 2, and the big step between version 1 and 2 is that we opened it up, just like Cytoscape has plugins. iSEE now has about a dozen extension packages. So iSEE itself provides the 8 what we call the core packages, the reduced in the call data, and so on. The extension packages provide the volcano plots, the FGSCA plots. So you can basically plot whatever you want if you invest the time to actually implement the panel.
Or if you beg hard enough with us. But
yeah, as long as the input object is and your panel knows where to sniff
that information,
find the data. So metadata is a wild card saying if there's no slot for it, stuff it in the metadata, teach the panel where to find it in the metadata, and then the world your oyster, and you can have a panel do anything like. But again, I'm sure you're going to close on that later on.
Yeah.
So this is where we are trying to, grow the iSEEk sub-community in Bioconductor, because we are just three, and Aaron either.
Yeah, but the point is that basically this thing has been kind of done on Purdue, so and none of us is paid for doing this, but we just care, so that's the problem.
Yeah.
One last question.
Yes.
I hope you presented this nice class yesterday with the ED experiment.
That fits.
The D and the FIA.
Yeah.
And because one of the questions we always have is how to present that dynamically, be Dia and Fia
Yeah,
to the
Yeah.
collaborators. So you think we can use those classes?
Depending on how fast and how much you annoy Najla for doing that, but yes, so like yes. So basically, DD experiment, that class will just fit in there because it's a single cell experiment. If you want to have, yes, yeah. So that's what one of the main reasons why we wanted to inherit from that, because we are basically just bringing water to our own mill, first of all, but also for the fact that you can actually think of, you can force the data type and the plot type in some kind of I would say it's not cheating, but it's actually using the features that are in there and make them work as they are, because we have a volcano plot panel, but we can actually simply go and take a raw data plot and then say I want to put the logfall change on the x-axis and I want to put the y-axis, and that has to be the log.
You don't have an official spatial plot,
But yeah,
the x and y coordinates of your cells in the column data.
And that's something that, I mean, we didn't do that, so but Jeff Moffitt's lab did that. So like they basically took a cold data plot, put an X, a Y, and they plot basically just like an H&E stained. So they have a spatial data plot. So you can think of I'm not saying cheating, but it's, let's say, exploiting the open ends of the software. So yeah. We are supposed to take a break. Like I would like you to take a break if it's a lot. So I would say like a 5 minutes break of air, and then we reconvene like on time here, or how is it with the time? Half an hour more. Okay, so I can. I think we have. Let's say, or I'm formally like I want to ask you: shall we take a break, or shall we just go with the flow and then we finish a little bit earlier? Go with the flow. Let's go with the flow. Okay. There was another question. Sorry, Bernard. I didn't oversee that, but it was that. Okay. Yeah. Okay. Okay. Yeah. So you can enforce it a bit. You can think of like putting it in some form. And if you work with microbiome data, what a coincidence that Giulio just came in. So Giulio, that has nothing to do with us in terms of affiliations and stock options on iSEE, because there are none. He was brave enough or forced enough by his group leader to work on something that extended iSEE and then did some kind of panels that were, let's say, specifically deployed for 3 summarized experiment objects. So dendrograms, check. So he might have this kind of tree-like representations. If you need that, then you can simply have, among the other panels that iSEE can give you in the initial configuration, all you need to do is to say, well, I just want another additional panel, and that's it. Yes.
And for the parameters,
yeah,
you need to see the things you want to see.
Then
you can have that and put another object.
Yeah.
Apply the same thing. Like this.
It might just work, provided that, for example, that let's say all the rows are in and all the samples might be having a similar names, which might not be the case if you have some column selection. But if it's just about having, let's say, if you want to start your app with just a couple of genes, then that thing should work. So you can actually recycle some things. And I think that the best part of it is that if something is not going to work, because some cells are not just in there, I don't think the app will crash. But it's more like it might fail gently. I cannot promise that. Or like fail silent, which actually might be nastier. Okay, I'm gonna do this. I'm gonna switch to the rendered version of the vignette, so that we can actually literally see what I'm saying, maybe. We can organize the iSEE panels. We clicked on that organize panels button, we move things around, and then we say apply settings, and that was that. We could have multiple panels of the same type. We wanted more reduced dimension plot because we wanted the UMAP plot color by that, the UMAP color by that, the UMAP faceted and color by that, and that, and that. We can do that. We can have transmissions among panels more or less the way that we want. If it's a row selection, it has to be a gene. If it's a column selection, it has to be a cell or a sample. You can color the points. You can do pretty much the hell you want. Just let's say a pen opener for a Pandora's box that I probably cannot really touch too much upon today. But if you don't like the colors within iSEE as they are in the vanilla version, you still can change that. We have the concept of so-called experiment color map, which is basically something that says, okay, for this particular type of categorical data and or for the specific metadata and column data, I want that color palette, then you get it. You want something else, you can configure that pretty much as you want. It just takes a little bit of time and fiddling. You can actually highlight and zoom. What I didn't show you, but I can show you like anytime, is that you can actually take this plot here, click over here, double click here, and then you're basically automatically zooming. That's actually given by Shine. We didn't reinvent the wheel on that. What we actually did, if you double click twice, then you go back to the original plot. What we did is that we have like even if it's not a plotly based plot, this is just pure ggplot, there is a JavaScript powered tiny little tooltip that can already tell you something more about what cell that was or what gene that was if we're talking sample assay plot. We can launch iSEE with a specified configurations. We have been putting that together. All we would need to do is then, let's say, click on that icon, display the panel settings, Control A, Control C, Control V, save that object, and then start the app by saying initial equal to the name of that object, which is normally initial, but it doesn't have to be like a tautologic version of calling that. If you want to export the code, you can just export the code. Kevin just touched upon the iSEE universe. So iSEEu, before COVID, it was a nice acronym. So nowadays it's possibly you might record of the intensive care unit. So it was an unfortunate one. We then went with the iSEE universe as the explicit way of calling that. We have introduced the concept of modes because we just wanted to have something like, maybe I want to use iSEE just for the specific application or use case. We had the application, the use case of having the reduced dim. So like the mode reduced dim, you just say this, and that becomes the app that has the PCA, TSNE, and UMAP. So imagine that you have more of the reduced dimension plot. You can just start the app with these three set of panels. If you want to use iSEE hex, that's basically a hexagonal reduced dimension plot. So if you want to display not just where the dots are, but also the information about the density of how many dots are there, you can do two things. I mean, you can also take the points here, make them smaller, increase the transparency, and then you can actually see that, or you actually have this elegant way of representing that. If you're working with, for example, with mass cytometry data, you might want to play with a mode gating mode. Takes an SCE, what plot assay do I need to focus upon, and what features do I want to just include in the first round of selection. So, and I'm here taking the top, I think it was the first 6, and so top 6 and top 11, 6 and 6, the most highly variable ones. And then what I would obtain is I would take basically the top variable genes across each other. So like S1A8 versus iSEE, and then you can have already like a pre-configured set that you can always change, but it is just to give you like a quick start. We became lazy with a tool that can make you even more efficient. I'm an engineer, so pardon me for that. We need to have this kind of, let's say, shortcuts and or other fancier stuff. That's, for example, this aggregated dot plot, which is possibly what you can see called in other tools as these bubble plots, or how does Seurat call it? Dot plot. No? So that's, yeah, that's basically it. So like, can you have all the beauty of the giginess of it? You can, for example, possibly like pass these, let's say you can have the selection of the genes that is coming live. So again, where it's going to be in the data parameters. How you can control how it looks like in the visual parameters. Do you want to pass something and you can actually select some of them and then have them split because that's the one that you selected versus the unselected one? You can control it here. And then there is one tiny little creature that came to life like last year. It was, let's say, playing to the extreme with the fact that we needed to get lazy / efficient / help our collaborators. So we are working a lot with immunologists that we love a lot, but then, and they would like to play a little bit more with lots of markers. And then, for example, starting with, configuration that just throw them into the middle of how the data looks like. So we will start by reading in the data. That's just the same data as we had. And then we are focused on 3, as in B, TGF-beta1, CD28. And then we want to consider that our clustering, our cell type should be the labels main. And then we use iSEEinit. So the functions inside iSEEfire spit you out an initial configuration that you can just take and then basically say, I'm going to iSEE that. And then I say initial is initial 1 or initial 2. So what are we doing here? We are focused on these 3 markers. We are focused on this cluster type. And we are adding a markdown panel because we also have a markdown panel to take notes live. And what this gives you is like a possibly, I'm going to make it smaller so that you can see that you get a fairly large app with just a few lines of code. You can get a full configuration of that focuses on the things that we wanted to focus upon and gives you this and gives you that, and focuses, for example, on, let's say, we said we wanted to split it by the cell type. It's already there with the coloring by the cell type, with the x-axis as a cell type. We wanted to have an additional one, and we want to have a placeholder like a markdown board, which is actually working live.
So this is where you can take notes.
This is actually, yeah, this I want to show you because it's actually quite cool. So, for example, if I jump to that, so I'm going to start from here. I'm going to load iSEEfire. I'm going to load the SCE file. And I'm going to say, I want to this and that. Then the initial one is a mouthful. That's actually the list view of that. But you don't need to know that it's that looks like that. You can actually simply say, you can view it as a tile so that you can have like an application. I told you it's a mouthful. So we can actually see how it looks like by simply having this kind of a app-like summary of that. So you remember that the reduced mention plot looks like this, then you have this and that, this and that. But you can also have like a tiny little network of how that thing looks like, because the column data plot will receive selection from these. And then let's say this one will talk to that, and that was it. But what I wanted to show you is actually the app itself. So all I would need to do is to say iSEE SCE initial is initial 1. And this gives me also a markdown board, which I can just edit with anything. I can say everything I1, and as soon as I stop doing that, or to stop typing, say this, say that. So I have basically markdown inside iSEE. And yes, if I click on the configuration, then I save everything. So you can take notes, you can focus on some markers that you want, type things there because it's easy, copy, paste, done. So you can see that it becomes fairly easy to start up the fire, and initialize quite fast. I see more or less the way that we want. We actually decided that it would be cool to be possible to stitch together a merge configuration. So we started by saying, okay, initial one, that's the one. Then initial two is another take on that. And it is basically focused on this gene and this other gene. And then this is initial two. I can glue them together and I can obtain a combined representation of that. This is initial one until here, until here, and this is initial two. It just, you can imagine that it becomes like a fairly 9 rows of the app, but you can at least have already an idea of how it's organized. And you can use this view tiles with any kind of initial object that you have. You can actually see more than one data set. Who has more than just one data set? Okay. You can actually have iSEE, iSEEhub, and iSEEindex. We can start by iSEEhubbing things. Who is familiar with the experiment hub? What happens there is that if I can simply say eHub, that's my experiment hub object. I can iSEEhub that eHub, and I obtain a representation of that inside iSEE, that if I simply run these lines of code, I have a fully explorable instance of the experiment hub that I can search for anything. I think it was maintainer and it was you and Angelo, Charlotte, so duo. So for example, I want to select these, get ready to be blasted away because you can say, I want to iSEE that data. It's a single cell experiment, it's a summarized experiment, perfect, okay? Then I can configure and launch, and I want to launch iSEE on that data. See what's happening here? It's loading that data, so it's caching it for you, or it's loading it from the cache in case it was already there. It's downloading that object. Wrong choice. 5 years later with this kind of connection. But you can imagine that not when it's done. Come on, let's just do it properly. See, which one was a small one? I don't know. Can we actually show off a little bit the iSEE.bioconductor.org? That is actually a running instance of a subset of that. It's not the same spirit. If it loads. But you can imagine, come on, let's think in green. So iSEEindex is basically taking the hub is anything. The hub is any collection of data set that you can load in some way. It has a concept of the loaders. So the loaders are something that gives you back an SCE object. And you can do it in different ways. You can vget those files. You can actually read them with an read RDS command. You can actually read it with a custom command in anything in R that gives you that. You can read it from AWS, from Amazon Web Services, because that's what's also in there. So you can imagine that if you have such a thing, I can tell you what's happening here. We are using basically what's deployed within the packages itself as an example data. We have different data sets, and we have different configurations of this initial. And then iSEEindex feeds on something that has to be a cache, because I wanted to make it temporary. I want a function that tells me how to get the data, a function that tells me how to get the initial configuration. And if I do run that, I can simply run this command. And you can see the spirit of this. So like we have the reprocessed AnnData and the Büttner ESC data. This is something that I'm pretty much sure that I have locally. So I select this data set, or I select this one data set. And then I launch this, it loads it. It just, oh. But it is faster. Okay, I'll talk over. So you can imagine what's happening in the background is it's checking in my cache. Is that thing there? Yes, no, it's not. Because of course it's not, because I've selected the new cache. So that's why. Basically, it will take this data set and will start iSEE on the configuration that I have here, which is the default. And it will basically just have one page, one website that serves multiple data sets. And you can imagine this can be like the new revolutionary tool that can work for your lab, because your lab might want to have multiple data sets that you want to explore internally, or even better, once you're done, ta-da, it runs iSEEindex powered by iSEE 22.21.1. And if you have ever seen the Allen dataset, that's the Allen dataset. I can test that with you by checking ROR-B, which is the expression of a special gene. So I can color this. So it's a new pan-neuron marker, or I can take FOXP2, and that was a specific one for, oop, it's coming. Feature name. Ah, yes, sure. I need to get it from here. So FOXP2 was a specific marker. What marker is that? Well, I can see that I can say, well, I want to see what driver one is, what primary type that L was. So I can select those, pass it from here to there. I think by now you might have get the gist that you can do pretty much whatever you want-ish. And that's an L6A MGP and L6A SLA marker. And then again, the magic wand is there for you to take a snapshot of this in terms of code. You can imagine that actually you are done with your project and you want to talk about these beautiful data sets and collection of data sets that you have. Someone was brave enough, or not just brave enough, but proud enough to have the idea to say, oh no, not now. ShinyApps.io. You had one job. Okay, I might have a screenshot of that. Yeah. Like literally. Opposite cloud. Okay. Yeah, you have to trust me on that. This group had a collection of 6 to 7 super cool data sets. They said, we present this data set to you in figure 2. And therefore, we have an instance of iSEEindex that serves this data set with a specific story and then tell you that story just there. And you click, and then you have access to their data live with their legend, and then you start exploring that. You don't. That's true. So yes, you're right. So the interferon resource is nothing but iSEEindex with a mask on. You can actually put pretty much whatever you want. You can put a table of your data sets. If you have site-seek data that you proudly want to show in figure 4, and you want to configure that with a configuration which is specific to your site-seek data set, it will start the app with a pre-configured set of many panels that will have a lot of content that we are very eager to guide you through. So you can take that tour and put it onto the different elements. And if you want to say, oh, wait, I want to focus on this subset of cells. And then let's go back to the other one. And you can see that since I changed the selection, then I will highlight only those. And that's all with one, let's say, all you need is one URL. Can be a local host of your locally running app if you have access to all the data, or something like this. Where were we? Okay, we were here. No. I think we were on the other window. So if you want to explore more than one data set, and if you're confident in doing it yourself, try it out. If you'd say, oh, I'm sure, but they just came to us and they said, can you help us in setting this up? And I said, yes, sure. More work, give it to me. But no, it's actually a super cool thing that they thought of our tool to actually display it for that. And I can tell you that editors might love these kind of things because you have a perfectly fantastic content for your data availability section of the paper. You say, not just that the data has been deposited to this or to that repo or to Zenodo, or as a cell by gene instance, the cell by gene team will say, oh, Jesus, this is something that our tool cannot do. And I say, well, that's why you do this and we do that. So you can actually say, has been deployed upon the local instance of your Shiny server and so on and so forth, and that's it. Maybe in the future, you don't even need to deploy it on a Shiny server because there is, if you remember Vince's snapshot yesterday of the roadmap, there was something here on the yellow side, there was something with iSEE WASM. So it can be that iSEE might run soon in your tab, in your browser tabs, without the need of installing things. We are silently and slowly working on it, I would say. Thanks to the guy also that actually gave us the infrastructure thing for the workshops. So Alex Mahmoud. And yeah, so I would say that normally I can close this with a kind of a couple of tips for some of the use cases that you might have. So in Germany, we used to say that alle gute Dinge sind drei, so all good things are three. So I'm just going to give you 3 tips for each of these use cases. But if you have, it shall be given. In your case, I'm just doing QC, dude. Yeah, well, you can open up the panels in the default mode. You can use the mode empty from iSEEu, so it starts ultra fast. You keep on coming, you keep panels coming, you store the configuration, and then you just open multiple panels of the same type and you start exploring. Sold. You're sold. Perfect. I need to explore the data in depth. So you might want to see the connection that you might have between the plots and the panels and so on. Well, you can just start doing that. You have these, whatever you want to create and store as an output. Actually, you can simply take, I didn't show you that, but you can simply take anything and say, save image as. That's a PNG. So you can take that as a PNG. And in case someone else is still keen on doing more, where were we? Yeah, you can take a snapshot of the code and you have it for bookkeeping and proper reproducibility. I have my lab meeting next week, right? So the typical use case, there's no need to rush it. You can just enter the lab meeting with this. So you don't have to be stingy on the panels number because you might just be ready for all the requests that your PI or your colleagues might have. You can have the initial configuration that you can store anytime and expand upon, and you can save all the output components. You're done with one data set and you want to publish it. We just went through that, so it's easy. You can choose a title. You can choose the content that you might want to put into this iSEEindex based component of that. That's a very important thing is to put together a story that actually tells the story that you want to tell. And actually, what I can show you is that we have this kind of, I would say, tour suggester. I don't know if it's in there. Yes. To know a little bit more of the tour, so you need to anchor something. So I'm just giving you, based on the panels that you have open, the name of the panel here, and then you can start expanding on the tour. It might be a little bit more complex than that. Within a use iSEE, there's a little bit more of description. You might need a little bit more of knowledge of this DOM, this DOM elements inside a web page. But for example, in this case, I would say a very good starting point, right click, and then inspect, and then you can see the source. Use the source, Luke, and then you can see the names of these thingies. So it might be the ID column data plot 2, and that's kind of suggesting you the name of the thing that you need to highlight. That's it. Yes.
Letting the non-R users play with this tool.
Yeah.
And
they don't get back to us, which is a good thing. Yeah, because in the end, so
they manage.
They do manage. They manage. So like we normally do two things. We give them like a 101. So we give them like a private session of this workshop basically for them, which specifically focus on their dataset. And then we kick them free into the wild world in a way that we basically show them, well, you might do this and do that. We have lucky enough that we normally work with clever people that pick up on these things. And then we, let's say, I have some proud moments of people that send me screenshots over WhatsApp of their configuration of panels, because that's what they will put in their manuscript. And that's, I mean, that's a nice moment, you know, just like they send you it saved me so much time as a feedback. They don't get back to us also because this is almost bugs free. So say we have a good amount of unit testing that actually makes sure that that people don't screw up. There's actually a fun option inside iSEE where you can actually show some bugs on the plots. Is it like a vector? Yeah. Or that, yeah. So you can decide how many spiders and how many bugs you literally have, or you simply have a couple of them. So whenever the plots will appear, there's a JavaScript-based trick to show some. And you can, like if you click on those, they fall down. So like you can kill them. I don't know if it's against the code of conduct in terms of animal harming, but that's how you can have bugs within iSEE.
You enjoyed that initializing, right?
Yes. I mean, okay. Fun fact and not a fun fact. You can control iSEE with your voice.
Okay.
I'm gonna demo that once we are offline because I don't want to record a fail. Because it's not Alexa, it's not Google Echo, so it's not. It's clunky, but it works. If you remember the meme of Jack Sparrow, it's the most ugly implementation of something that works with a voice, yet it works. So I can show it to you later. But 4 minutes, perfect. I think I'm very much on time, but I can say I have a collection of data. We've been through that. I'm just interested in looking at the markers. So you have iSEE init and iSEE marker within iSEE Fire that can be. Yeah, you can, as Najla, you remember that Najla showed that, right? So the experiment can just fit inside that. So if you want to check the experiment, the result of a pseudo-bias-DE analysis, you can just do that. And here there is a compact way. So that's basically from her slides. That's the code that she used. So you can try to see if this just one works. Otherwise, you might need to adapt it briefly. And yeah, where's Julio? He's gone. No, he's still there. I feel almighty and I want to develop a new panel type for iSEE. Where can I start? We have some kind of resources. They have this iSEE book. that we put together. Actually, we can ask Giulio, how was it for you? Like, was it such a pain? You can lie, but where did you look first?
Slack, we were still on Slack, Kevin and you, and work. And then I went through that book.
Yeah.
At the end, it was pretty hard to develop the first panel class, but once you know how the different methods and stuff like parts of a panel work, it's easy also to create other panels.
That's true. And you did it before last year's workshop, which is actually was dedicated to let's create a new custom class together. So sorry about that, but let's say timing was not on your side for that. Yeah, and then just a quick rundown on the iSEE main parameters. I mean, we have the initial that right by now you should know what that does. The color map chooses the colors. The landing page controls how the whole thing is displayed first. The tour is your friend to take someone by the hand. The app title and the title were two suggestions that Giulio also had for having something that looks like fancy also inside the tab title. You can control iSEE with your voice, and you can have bugs on purpose. And maybe just this as a big piece of evidence that you can use for many data sets. So we have the Mia Dash that Giulio was presenting yesterday in the poster session. There are other people that were, let's say, curious and brave enough to provide their instance of iSEE on their dataset when the paper was published, and I'm pretty proud of those people and of the fact that they trusted us to work with their unpublished data so that we can put together such a cool thing that once the paper is out, they have a beautiful set of figures that we can just show to people. So it takes a while to load, but let me see who is loaded first. I think Mia Dash. So see, the microbiome analysis dashboard, and then that's what Giulio demonstrated yesterday on the poster. I don't know if it's possible to demonstrate on the poster, but. See, you basically say, don't I see?
Big data set.
But for example, the group of, I think it's Leo Collado Torres, right? So they did some pseudobulk on HPC spatial data, but now it's possible. So it fits, it sits, it's possible to just create something that they, for example, use to explore further or try to say something more about that. And if you want more, I mean, there's the I use iSEE repo that can actually have even more information than this compact 2 hours workshop. Otherwise, thank you for being here. I hope it was a learning thingy for you.